Hey, what's up, guys? I'd like to continue our journey through elementary geometry, at least picking and choosing the areas and concepts I find most interesting and thought provoking and useful, perhaps. And the first one is arc length. And when we think about arc length, it's the measure of how long a curve is. This is really valuable, I think, throughout all of mathematics and engineering and physics to think about how long this arc is. And there's some cool ways we can figure it out. First of all, we know a formula for the circumference of a circle to be 2 pi times the radius of the circle. But we don't have a circle here, so what are we going to do with it? Well, this curve represents a portion of a full circle. So we can actually measure the angle, perhaps with a protractor, or maybe we're given the angle. We have our radius. And then we could determine exactly how far this length measures by taking the ratio of the angle theta and dividing it by 360 degrees, assuming theta is in degrees. And then that will give us our arc length. This is a valuable formula indeed. And if you think about it, this works because if we're just measuring a portion of the circumference of a circle. This wouldn't work if perhaps we were measuring a curve like this because it changes directions. We have to find exactly where it stops curving downward to form a perfect circle and measure it from a different angle to get two different partial circles. And then we could find the arc length S1, S2. And so in addition, we can build off arc length by thinking about what's the area of these partial circles. And again, we just build off the concept that we just demonstrated, and that would be that we would take our angle again, divided by 360 degrees, but this time we just multiply it by a formula for an area of a circle, which is pi r squared. And this will give you the area of a partial circle.